Nothing ruins a great evening like a speech. So try to make it as short as possible, but also give due to our awardees tonight. Thank you for attending this evening to celebrate the accomplishments of two outstanding engineers and scientists. Hope you enjoyed your dinner and the camaraderie around the table. I'm very pleased to take this opportunity to recognize some special guests and supporters. First, Dr. Ken Gabriel, President and CEO of Draper, and the Honorable David Shedd, Chairman of the Board of Draper. Gentlemen, please stand. We'll give you a It's a wonderful event, and it's kind of the definition of first class. I really appreciate it very much, what you're doing. Also, Dr. Dan Moat, President Emeritus, National Academy of Engineering, and his wife Patsy are here, so maybe you two could stand and we can do some applause. Dan's more comfortable tonight because you have to be up here giving this talk, right? And since this is Engineers Week, let me introduce, I think Mrs. Kathy Renzetti is here, Executive Director of Discover E, which organizes the week of activities. Where's Kathy? Engineers Week, as it's called, involves more than 70 professional, educational, and cultural societies and more than 50 corporations and government agencies. It is dedicated to raising public awareness of the engineers' positive contributions to the quality of life and motivating young people to pursue engineering careers. The Engineers Week theme this year is Engineers, Pioneers of Progress, very fitting for tonight's agenda. Finally, I would like to acknowledge the executive directors of other engineering societies, members of the Draper Prize Selection Committee, and of course, the many family members, friends, and colleagues of this year's Draper Prize recipients. How about a round of applause for them? The Charles Stark Draper Prize for Engineering honors the engineers behind the world's most significant engineering innovations. To date, 54 engineers have received this honor. Tonight, we add 2 more to that distinguished list. Now let's take a look at the legendary engineer behind this prize, Doc Draper, and tonight's awardees.
The Charles Stark Draper Prize for Engineering was established by the National Academy of Engineering and endowed by the Charles Stark Draper Laboratory Incorporated in 1988 to honor the memory of Doc Draper, the father of inertial navigation, and to increase public understanding of the contributions of engineering to the freedom and well-being of humanity. The prize recognizes engineers responsible for technological developments that have transformed modern life. His belief that education needed a hands-on component led him to establish the instrumentation laboratory within MIT's Aero Department. In 1973, MIT divested the laboratory, thus creating Draper, an independent, not-for-profit engineering solutions company. The Draper Prize acknowledges working solutions rather than theoretical discoveries. Examples of past winners include the creators of the GPS, inventors of the cell phone, and pioneers of personal computers and the Internet. Without these remarkable engineering achievements, much that we take for granted in our day-to-day lives would not exist. The 2020 Draper Prize is awarded to Jean Frichet and C. Grant Wilson for the invention, development, and commercialization of chemically amplified materials for micro and nano fabrication, enabling the extreme miniaturization of microelectronic devices. Chemically amplified resist, or CAR, is used in lithography to create the very small structures in modern semiconductors. At the time of their innovation, the semiconductor industry was approaching a technical limitation in how small those structures could be made with existing processes, short waveform light sources needed for the higher resolution circuitry were too weak to be used. The development of chemically amplified resist materials allowed for higher sensitivities, which reduced photoirradiation time and ultimately allowed for increasingly smaller structures to be created. Frichet has worked at both the University of California, Berkeley and the King Abdullah University of Science and Technology. A member of the National Academy of Engineering and National Academy of Sciences, Frichet has been selected for numerous international honors, including the American Chemical Society ACS Arthur C. Cope Award and the Japan Prize. His work in polymers has garnered over 120,000 citations. Wilson has worked at IBM and currently holds the Rashid Engineering Regents Chair at the University of Texas at Austin. His research focuses on the design and synthesis of functional organic materials, with emphasis on organic materials for microelectronics. He was presented with the National Medal for Technology and Innovation 2008 by the President of the United States, and in 2013 shared the Japan Prize with Frichet among numerous other honors. These materials created by Frichet and Wilson are used in the manufacturing of microprocessors and memory chips found in everyday modern devices that have become vital to our way of life. Personal computers, mobile phones, motor vehicles, the entire Internet of Things are enabled through the innovation of CAR created by Jean Frichet and C. Grant Wilson. And for this, we award to them the 2020 Charles Stark Draper Prize for Engineering.
Ladies and gentlemen, please welcome Dr. Ken Gabriel, President and CEO of Draper, who will share a few words about the Draper Prize and assist us in the presentation. Ken?
Mark Twain is credited with saying, "History never repeats itself, but it does often rhyme." Tonight, we're here to actually celebrate and recognize one such rhyme. At the dawn of photography, nearly 200 years ago, there was also another duo, one a native French speaker, the other a native English speaker, who, while perhaps not working quite as closely as Jean Frichet and C. Grant Wilson did, nevertheless, they produced chemical films sensitive enough to capture light. Louis-Jacques Mandé Daguerre and William Henry Fox Talbot. Like tonight's medalists, Daguerre and Talbot were out to solve a problem, to create a new capability that had never before existed. That pursuit of technologies and innovations to not only discover, but to deliver new capabilities is the essence and mission of Draper and the Draper Prize. And it is the essence and mission of engineering. Joining us tonight are Ala Gimbel and Hina Mutha, representing the next generation of innovators at Draper. They and their colleagues will be creating new capabilities that have never before existed. I look forward to seeing what you all come up with, but judging from history, you may want to start looking for some native French collaborators. Merci et santé.
Good. Thank you, Ken. The recipients of the Draper Prize share $500,000 cash award. Then each receives a commemorative medallion over here and a hand-lettered certificate. I'm going to warn the recipients right now to be careful because the check is behind the certificate, so don't lose it. The recipients of the 2020 Charles Stark Draper Prize for Engineering are Professors Jean Frichet and C. Grant Wilson for the invention, development, and commercialization of chemically amplified materials for micro and nano fabrication, enabling the extreme miniaturization of microelectronic devices. The chemically amplified resist CAR abbreviated materials created by Frichet and Wilson are used in lithography to form the minute structures that make up today's semiconductor devices. These materials are now used to manufacture nearly all the microprocessors and memory chips that enable electronic devices such as personal computers, mobile phones, and motor vehicles. At the time of the invention of CAR materials, the semiconductor industry was approaching a limit. The existing lithography process and the available resist materials being used in the fabrication process could not form the smaller images required to continue improving devices, so-called to extend Moore's law. High-resolution light with shorter wavelengths was preferred, but such light sources were very weak in output. The method of chemically amplified resist materials developed by Wilson and Frichet provided higher sensitivity, which improved production efficiency by reducing photoradiation time for image formation and enabled the production of much smaller structures in shorter time. Now, as I call your name, I invite each of the two award winners to the stage to receive your prize and have your picture taken. After both winners have received their prizes, we will gather on stage for a group photograph. Professor Jean Frichet, Emeritus Senior Vice President for Research, Innovation, and Economic Development at the King Abdullah University of Science and Technology, and Emeritus Professor of Chemistry at the University of California, Berkeley. Professor C. Grant Wilson, Rashid Engineering Regents Chair, Department of Chemical Engineering, University of Texas, Austin. I now invite Professor Wilson to offer remarks.
Thank you very much. My goodness, what an amazing honor. So the organizers of this wonderful event told Jean and I that there was only enough time for one of us to speak here tonight. And Jean flipped a coin, and I'm not sure whether I won or lost, but there was some kind of chance-based decision made that I would tell you a bit about the thing. So I'm hoping to do so. I was chosen by chance, but sharing the prize with Jean is a huge and really a totally unexpected honor. This award is known throughout the world as the Nobel Prize for Engineers. It's not a local recognition, it's a worldwide recognition of the importance of this honor. So it was overwhelming to find that we were considered for this prize. The previous winners include many of the most famous and scientists and engineers that we've known during the period of our, Jean and I, during the period of our work and our professional careers. I think the first prize was given in 1989 to, it was Jack Kilby and Robert Noyce, who were honored for their development of the integrated circuit. And it's hard to imagine that we might be even considered to be included in this amazing list of people who have won this prize. It's also humbling to think about how many friends and people, colleagues and coworkers who donated their time and energy to writing the many nomination forms and letters and so forth required to put us here on this podium. And also the members of the committee that was put together by the National Academy of Engineering to make the decision of who should win the award. They worked hard and long to look at, I'm sure, many, many people, and amazing, and we're very grateful to them and all of those people, both Jean and I. Special thanks goes also to our wives, my wife Debbie and Jean's wife Janet, who sat through many missing dinners and long nights while we were in the laboratory working on these, on the things that led to the discoveries that we're describing. It also affected Jacques, who's sitting there next to his mother, and my sons Andrew and Billy, who wondered where the world their father was many times, and were willing to tolerate and put up with our absence. There were many long days and nights that were dedicated to the work that led to this honor. The thing that was, I think it was described very well by Dr. Anderson, that the work was inspired by a need to reduce the cost of IBM's manufacturing of semiconductor devices. And in the late 70s, we had been reducing the size of the structures that were being built and reducing the cost and improving the performance of these devices at a constant rate defined by this famous Moore's Law. And suddenly it became clear that this was not going to be possible any longer, and the performance was about to plateau. And so there was great concern not only within IBM, who was making the most silicon devices of anybody in the world at that time, but amongst the world community as well. And so it was, when I first came to IBM, I decided that if I was going to make an impact, the place to do it was to try and deal with this Moore's Law problem, which in fact was a chemistry problem. And almost everybody in our laboratory were engineers, electrical engineers, and people who were not trained as chemists. And so I thought, this is a chemistry problem. I'm going after this. And so I was working on it when my boss came to see me one day and said, there's some weird French guy who sent a letter to the laboratory asking if he could come and spend a sabbatical year studying at the Almaden Research Center, well, at the San Jose Research Center, IBM. And he said, Grant, would you be willing to mentor this person? Because somebody has to take care of him. Make sure he doesn't get hurt or do anything. So I said, golly, I don't know if I want to take on that responsibility. So I went to the library and looked at a set of papers that this fellow Frechet had written, and my goodness, they were impressive. So I decided, yeah, sure, I'll take this guy on. Well, it turned out that that was a really wonderful decision, and we have become co-workers and friends for over 40 years. Jean is not only a great friend and collaborator, he's the godfather of my son, and we spent a lot of time, yeah, stand up, Andrew, there you go. Yeah, and so anyway, we decided to set off, and almost fairly quickly in discussions we had in my office, explained to him what the problem was that we were trying to solve, and fairly quickly in the process of this discussions, I can't remember the details of it anymore, of course, but we came up with the recognition that this trick of using catalysis to do the work was the potential solution. And then there was a lot of time spent trying to, once the design concept was clear, trying to come up with the specific chemical entities that are required to make that happen. And Jean and I were working together really right in the laboratory, pouring liquids from one flask to another and shining light on thin films and so forth, and really doing the experiments ourselves. It was great fun. When Jean went back home to the University of Ottawa, where he was on sabbatical from at that time, we had already demonstrated the principle of the invention, and it was clear that the principle was correct, but there was a lot of detail to be sorted out. And so when he went back, we continued to collaborate over distance, and IBM supported some of his students, and we continued to communicate and exchange materials and work closely together for many years before and after he went to Cornell and then finally to Berkeley. When he left, I felt terrible loss, obviously, and so I decided I need to find somebody like Jean. So I went to the University of Syracuse in New York, where he had earned his PhD, and I went to his PhD advisor's research group, and I met with his advisor, Konrad Schirsch, and asked him, do you have another Jean? And he said, maybe, and introduced me to a young man named Hiroshi Ito, who was a postdoctoral, and he came to IBM as a postdoctoral fellow, and he and Jean and I continued to collaborate for many years to push this technology forward. And Hiroshi made many important contributions to the project. He unfortunately passed away in 2009, but before that he was actually hired by IBM as they have a rule against hiring postdocs. You're forbidden to hire a postdoc and continue them there. But was a friend of mine who was working at Bell Laboratories. At that time, his name is Larry Thompson. He was the manager of the Resist Development Group at Bell Laboratories, and they were competitors. We were competitors, but friends. So I called Larry and said, I want you to do me a favor. Find a piece of Bell Labs letterhead and write a letter offering Hiroshi Ito a job at Bell Labs with a very high salary and medical support for his wife. And so Larry did that. It was a completely false news, fake thing. And I'll be darned if it didn't work. And they hired Hiroshi, and he ultimately became an IBM Fellow, which is a very vaulted position. IBM Fellow has the opportunity to do anything you want for the rest of your life and be paid. It's a very wonderful and unusual position. But I'm sorry we lost Hiroshi. He certainly would have been standing here with us had he survived. Jean and I both treasured the Draper Prize, and we will continuously remind us of how lucky we were really to have had the opportunity to work in the really beautiful, efficient, and terrific freedom and so forth that was in the IBM laboratories at the time that he visited that year. And it will also remind us how lucky we were to work with, for me, it will certainly always remind me of how lucky I was to work with people like Hiroshi and Jean. And I'm a very humbled and grateful man. And I'm sure that boy is too. That boy.
Leave them on stage.
Thank you, Jean and Grant. We are honored to celebrate your award this evening. Please join me in one last round of applause for these two great men. I wish to thank everyone who participated and all our guests who joined us in the celebration of the 2020 Charles Stark Draper Prize for Engineering. Again, I want to thank the Draper Corporation and Foundation for making it possible for us to do this. It's, as Grant said in his talk, it's global in its recognition, and it's really important for the field of engineering to be able to point out such accomplishments that have affected our lives of nearly everybody around the world. I also want to thank the staff, which has done an outstanding job of planning and executing this event, especially Deborah Young. Thank you very much. And finally, I would like to thank the committee that selected these two outstanding people. They put a lot of hard work in. It's not easy to do this because the nominees are all very, very good, and you've got to dig deep and consider all situations. They did a great job. I was able to observe this, and I want to thank them, the committee that awarded the Draper Prize this year. Thank you. Okay, now it's time for dessert in the West Court. Enjoy, talk, shake hands with the winners, and let's have some more fun. Thank you. Yeah, we need some photos.
They want to get a picture. Yeah.
More pictures.